This question involves a multitasking principal and agent problem where the principal can only incentivize task 1. This is shown through the wage equation W equals alpha plus beta x1, where x1 equals E1 and x2 equals E2. This shows that the principal's choice of beta will only affect the effort level of task 1. The utility functions of the principal and the agent are shown as such. The game is played in the usual way. The first step, the principal chooses the wage function that it offers the agent. In the second step, the agent can either choose to accept or reject this offer. And the third step is the agent choosing its utility maximizing levels of E1 and E2 if it accepts. So for part A, we're told to find the utility maximizing levels of E1 and E2 in terms of beta. In order to do this, we're going to sub in the wage equation into the utility function of the agent to give us the following equation. In order to find the levels of E1 and E2 that the agent is going to choose, we're going to take the first derivative of UA in terms of E1 and E2 and letting this equal to 0 to find the maximizing levels. So, taking the derivative of UA in terms of E1 and letting it equal to 0 gives us the following equation for E1 equaling half 2b beta minus E2. Doing the same steps but in terms of E2 gives us a level of E2 equals negative E1 over 2. Now in order to find these two terms in terms of beta, we're going to have to solve them simultaneously. So now we just have to sub E2 into the value of E1. This gives us a value of E1 equals a half 2 beta plus E1 over 2. Timing both sides by 4 gives us 4E1 equals 4 beta plus E1. And then subtracting E1 from both sides and dividing by 3 gives us a value of E1 equals 4 beta over 3. So now that we have E1 in terms of beta, we simply have to sub this in to the value of E2. This gives us E2 equals negative a half times 4 beta over 3, which gives us E2 equals negative 2 beta over 3. This negative value means that not only is the agent not putting any work into task 2, but is actually being counterproductive and letting x2, the output, equal a negative value. Part B asks us to find the levels of alpha and beta that the principal is going to choose in order to maximize its utility. Now, as the agent can choose to reject the offer that the principal offers it, the principal will have to offer a utility to the agent that is greater or equal to that of the rejection offer, which will give the value of U0. Now, if it provides a UA that is greater than U0, then it's giving the agent greater amount of utility that it could otherwise be keeping for itself. If it gives a value of UA that is less than U0, then the agent is going to reject the offer. Because of this, the principal will make sure that the utility of the agent is exactly equal to U0, and thus UA equals U0 and UA minus U0 is equal to 0. Because of this, we can rewrite the utility function of the principal as so. UP equals UP plus UA minus U0. Now, subbing in the equations of the effort levels for UP and UA, we have the following equation for UP. To find the maximizing level of this, we're going to sub in the levels of beta that we found in the previous question and simplify this to give UP equals 2 beta over 3 minus 2 beta squared over 3 minus U0. In order to find the level that the principal is going to choose for beta, we are going to derive this and let it equal to 0 to find the maximizing level of beta. This gives us an equation 2 over 3 minus 4 beta over 3 equal to 0, and simplifying this gives us a beta level equal to a half. So as we found out before, the principal is going to choose a alpha level that lets UA equal to U0. We also have this other value for UA equaling wage minus the effort function for the agent. So if we let U0 equal this equation, then we get U0 equals alpha plus beta E1 minus a half E1 squared plus E2 squared plus E1 E2. If we then move alpha to the other side and sub in our values for beta, E1 and E2 that we found previously, and simplify this, we get a level of alpha equals U0 minus a sixth.